Hey, this is Mr. Ward, and I am doing a video key for PreAlgebra Exit Ticket 22.1. That's week 22, day 1. So we're going to evaluate the scientific notation 4 times 10 to the 5th times 3 times 10 to the 6th. And if you recall, the key to doing scientific notation evaluation is to break up the coefficients and group them. So I'll just break it all up, regroup the coefficients, so 4 times 3, and then the powers, 10, and do the operation separately, or should I say in groups, 10 to the 5th times 10 to the 6th. Now, the 4 times 3 will be a 12, and the 10 to the 5th times 10 to the 6th will be 10 to the 11th. But we're not in scientific notation format yet. So we need to move the decimal in the 12 over 1. So we're taking a factor of 10 out of 12, okay? And that means we had to put the factor into 10 to the 11th. So that becomes 1.2, because we made 12 10 times smaller, times 10, not to the 11th, but now to the 12th, because it had to become 10 times bigger. So 1.2 times 10 to the 12th for the win. There we go. Now we've got 3 times 10 to the 4th to the 3rd. And once again, what we need to do is we need to do the operation. The relevant operation is cubing to the 3rd power. Do that to the coefficient and to the power of 10. So 3 to the 3rd times 10 to the 4th, also raised to the 3rd. And then we'll say 3 to the 3rd is 27, 3 times 3 times 3. And 10 to the 4th to the 3rd power is 10 to the 4 times 3. So that's 10, because it's 10 to the 4 times 10 to the 4 times 10 to the 4, which is 4 plus 4 plus 4, or 10 to the 4 times 3 power. And that ends up being 27 times 10 to the 12th. But we're not in scientific notation format yet. This is perfectly legit mathematically. We need to move the decimal over 1 here. So we're going to make 27 10 times smaller. So it's going to become 2.7. And fun fact, I know that wasn't supposed to be a comma, but fun fact, in Europe, a comma does the job of a decimal oftentimes. So 27 became 10 times smaller to 2.7, which means 10 to the 12th has to become 10 times bigger, and now it's going to be 10 to the 13th. And that is going to be our answer right there, 2.7 times 10 to the 13th. Now we're going to divide. So we got 8 times 10 to the 20th divided by 4 times 10 to the 5th. And again, we're going to separate the operation on the coefficients. That's going to be 8 over 4 times 10 to the 20th over 10 to the 5th. Okay, and so 8 divided by 4 will just be 2, and 10 to the 20th divided by 10 to the 5th will be 10 to the 20 minus 5. And so I end up with 2 times 10 to the 15th, because 20 minus 5 is 15. So let's find that over here. 2 times 10 to the 15th. All right, last one's more complicated. So let's look at all the pieces. So once again, we're going to organize our coefficients first. So we got 4 times 10 to the 7th times 6 times 10 to the negative 4th, all divided by 2 times 10 to the 5th to the 3rd power. So this is to the 3rd power. So we've got to say 4 times 6 over 2 to the 3rd power. And that's going to be times 10 to the 7th times 10 to the negative 4th over 10 to the 5th, and that is raised to the 3rd power. Okay, so we organize all this. This up here becomes 24. The numerator is 24. 4 times 6 is 24. The denominator is 8 because 2 to the 3rd is 8. And then over here I've got 10 to the 7 times 10 to the negative 4, so I'll deal with that. Up here, 10 to the 7 plus negative 4 is going to be 10 to the 3rd. Okay, and then down here I'll have 10 to the 5 times 3, so that's 10 to the 15th. Okay, now let's start simplifying. 24 divided by 8 is 3. So that becomes 3. And this becomes 10 to the 3 minus 15, which is negative 12. And we are done. 3 times 10 to the negative 12 is the answer.